Hi, I thought I'd give an example to clarify or to give some background about how you might think about this homework number 5, problem 5, that does upsampling. So here he talks about upsampling by linear interpolation. So the picture is pretty intuitive. Here's the signal that you start with, and then you think of this as taking samples at integer times. And then suppose your sample rate increases by 3 times. So you take 2 samples in between each one of these samples. Then you get something like this. Now he still labels it as an integer, but you can think of this as this is looking at a different time scale, but it's easy to transfer between these two time scales, right? This 3 corresponds to this 1, this 6 corresponds to this 2, etc. So the question is, if I want a finer approximation of this signal at a finer time scale, I wouldn't want a signal that's so jagged like this. I'd want a signal that smoothly goes between the points. Now he talks about linear interpolation, and I thought I'd give you an example that's related, similar, but a little bit different, just to use so you can see how this works. Suppose you want to convert the upsampled signal to a series of step functions. Right. So this point here becomes a step function. So the 3 values are the same. This point here becomes a step function also. 3 values are the same, and so on. Okay. So then the question is, how do you get this using a convolution? All right. Now there is a technique you can use, and it depends on linearity. You can think of this signal as a bunch of impulses that are displaced in time, right? Each one of these is like an impulse. This is an impulse at 0, this is an impulse at 3, and so on. So the response to the signal is going to be the sum of those impulse responses. Now, think of what happens to an impulse if I want to change this signal to this signal. Well, this impulse here was repeated 2 more times, right? This signal here was repeated 2 more times. So that's really the key to the problem. That one impulse becomes the impulse repeated 3 times, right? This impulse displaced by 3 becomes that impulse displaced by 3 repeated 3 times. All right? So in any impulse gets results in a function like this, which I wrote y of n. It's 1 for n equals 0, 1, 2, and it's 0 otherwise. Okay. Now, the convolution equation in general for discrete signals is f compose g of n, f convolved with g of n. You have this summation, this infinite summation, where you reverse the argument in g. Okay. Now, suppose I don't know g, but I can find convolutions of arbitrary functions. So suppose I don't know g, I want to find g, and I can plug in whatever f I want to find out what g is. Well, let me replace f by the impulse. Remember what the impulse is. The impulse is delta. Delta is 0 except when n equals 0. Okay? So I replace f with delta. I get a delta here, delta of m, g of m minus n. Remember, delta of m is 0 only when m equals 0. And delta m is 1 when m equals 0, and 0 everywhere else. So in fact, this infinite sum becomes a single term. And that single term is the term when m equals 0. So when m equals 0, I have g of minus n. Okay? So this impulse response is simply the filter reflected, right? So all I need to do is figure out the impulse response and reflect it in the y-axis. Now, in the case of linear interpolation, you need to think about what the impulse response would be. It's a little bit more confusing, but one way to do that is here, let me grab this picture again. There it is. Okay, I'll copy it. One way to do that is think about this. Whoops. Sorry, I wanted to do this. Okay, and let me paste it. Okay, and put it here. Okay. Now, one way to do this is think about if this is going to be, let's see, this is w of 0, and this is w of 3. If I do linear interpolation, what is this value going to be? It's going to be a combination of W0 and W3. In fact, it's going to be, if you work it out, it's going to be 2/3 times W0 plus 1/3 times W3. Okay, all right. Now, what does that mean? If I didn't have the W3, I just have 2/3 W0. All right. This point here also, the value of the function is going to be some combination of W0 and W3. What's the combination? Well, you take the combination and then you ignore the W3 part and see the W0 contribution. Now, this value here is not going to contribute past 2, right? Because once you've reached but up to 2, you don't use this value W0 to interpolate these points. You do use it on the other side. All right, so you're going to have a impulse response on both sides, all right? But you can pull the impulse response off by looking at these coefficients and ignoring the other coefficients. Okay, so I hope that helps a little bit and maybe give you some insight into this problem.